This is part 2 of the June 11th, 2014 GEO503 lecture. We will continue talking about individual layers in a map service. We bring up an instance of Chrome. We'll keep that in the background. As I mentioned at the end of the first section, individual layers in a map service can be accessed through an index number starting from the beginning of the MXD that created the service. Pictured, you see an ArcGIS Online service representing the demographics map that ESRI has developed. And we will know that the MXD that created this map service had one group layer in it with 4 sub-layers in the group layer being average household size, and then block groups, tracts, counties, and states located within that. We can click on and notice in the URL string, the previous examples we saw stopped at map server, the /3 on the end can bring us directly to the REST endpoint for a particular layer, in this case counties. The REST endpoint will give us metadata about the layer, you can see description here, and any other properties, minimum scale, maximum scale, etc., its spatial extent. If the individual layer is cached, we get information about the scales of the different cache levels. This picture here shows a single fuse map cache, where there are 8 discrete levels at which the map service can be viewable. This would be an ArcGIS tiled map service, which we'll talk about more in a couple of lectures. The individual layer in a map service also gives us information about how the layer is rendered. The legend from the table of contents is actually broken down here. We talked about class breaks renderers in desktop programming. We'll talk about that also later in this course. But you can see a class breaks renderer is a renderer where colors are broken down by ranges of values. We can see here the ranges listed with class maximum value and then the label. For example, the second bullet shows a class with a maximum value of 2.4. The label in the legend is 2 to 2.4 people. The symbol gives us an RGB value of the color used to draw that range. We'll also indicate other information about the layer, such as whether it has linear referencing or Z 3D values available, whether the layer supports attachments. In ArcSDE and ArcGIS Online, layers can be set up to support collecting of attachments and posting automatically from the field. We also see the list of fields in the layer. Not only just listing the fields, but the presence of an alias, field type, length, etc. So for example here, if I go to the REST services page for ArcGIS Online, I can go to some of these subfolders. I'm not going to pick that one. World Boundaries and Places, for example, is a tiled fused map cache service. And notice it's a map cache with 19 different levels. For each level we see the maximums, the scale, we see the resolution, and so on. Sometimes you can click on End Tile and see something, but not in this case. And here we see the metadata about this map server. It has one layer in it that's cached, World Boundaries and Places. The map presents county boundaries, and what we call first order administrative boundaries for most countries. We open up the service in JavaScript, you'll see that it contains, it's very hard to see here, states in the United States. for, this is not coming through on the video, it has states of Germany and so on. One of the things we can do with a REST service is access a legend. So I think I'll go back to the demographics. And I choose median household income. Here's an example. We saw how we see the different layers and so on. I can click on legend, and this generates a legend similar to what you would see in ArcMap for the layers in the map. So again, that's done by going to the to the map server and clicking on the legend. At the bottom of a map service, we have a list of things we call supported operations. These list the available requests for a service. Clicking on any of these hyperlinks will reveal more details about that particular request and how we would go about doing it. So this median household income, you can see here, supports a variety of requests: export map, identify, find, return updates, and generate KML. Requests can be made directly, in this case by entering the appropriate information, and we'll go through some examples, but in each case we can click on the upper right. The API reference gives us more details on how to fulfill a request. It'll bring up a page such as pictured here. So I go to generate KML. How do I do that? I can click on API reference to tell me. It's going to take a second to come up. I'll go back here. That's actually is not a very difficult one. I can call it, give it a document name, and I can choose which layers I'm interested in. I also have layer options. Do I want a composite image? Each layer is a second image. I'll put vector layers as vectors in this case. Generate KML, and here is my KML. Particular one does not want to show up. One thing we can go back and look at is another example, such as the export box example. Export map is another supported operation on this service. Here we see the default map. I can enter a bounding box, and if I wanted to know the format of the bounding box, I can click API reference. Here, it doesn't explain that much, does it? But I know this represents X minimum, Y minimum, which would be the lower left point, and then X max and X max and Y max is the upper right point. Or do something like this, and I've entered some similar values before. There's a bunch of other parameters, but if I just hit map get, notice I've retrieved. You see the map is created here. We'll talk more about get versus post in a second. I can retrieve a JPEG. I could create a PDF file of the map through the REST export. It looks like the ArcGIS Online site is stuck again. So I'll come back to that. We'll talk about this now. There are two main ways to send a request to a remote server. And you saw me click GET. There's GET and POST. To send a request, and the difference to you at this level does not mean much. They both act similar. We'll talk about the differences here. GET is a default request operation. When an operation has been requested, as well as the parameters, we start over. A URL is built with a GET parameter, with the service URL as the base, the name of the request, and then any parameters that were included, such, for example, the bounding box that I just made. So that URL is then sent to the server, and a response is returned. The advantage of GET, it's very easy to read. It's right in the URL. So this was a GET. It got an upstream error, but you can see what I mean here. Here's the server. The name of the map service is clear and easy to read. The request was export, and then the parameters indicate the bounding box that I chose. So a GET operation is very easy to read. Now back to this example, notice I chose PDF. Let's see if this worked. And sure enough, we can use the export map to create a PDF. There are only a few times when GET is not appropriate. In some instances we would use the other method POST, although we would almost always use a GET request. In some cases though we need to use POST because the length of a URL string cannot exceed 1024 characters. Now you might think, and you'd be right, that that doesn't happen very often, but it does happen. GET cannot be used if the number of requests would exceed this limit of a URL. GET can also not directly change the server. You're just requesting information. For example, you can use, and I've done this on several projects, I'm working on one this week, you can use these REST tools to actually delete a feature from your feature class. You would not be able to use GET for that because it's a change on the server. It's a security limitation. Imagine the mayhem if people could change things on your machine simply by sending a web page to it. So this is a purposeful security limitation against using GET for those type of things. A POST, the other option, does not include the request as a parameter. It sends the request via a form action on an HTML page. For this reason, the request cannot be bookmarked. I'm not sure if I mentioned that a couple slides ago, but one of the other advantages of a GET, as we saw how it's a URL, that means the URL could be bookmarked. So if there's a particular operation you want to repeat, you can just bookmark it. With a POST, you cannot do that because it's not URL based. We talked about form actions a little bit when we discussed HTML. Well, the POST utilizes that type of scenario to make the request. So you would use POST when some of the conditions from slide 27 apply, but normally you would use GET. So notice in the slide, I clicked POST. There's not any URL argument information like we saw with GET, but the response was returned here. And in the next section, we'll talk about REST responses.